Yeah, let's start. So my name is Stanislav Rogovskiy, as you can see on the slide. I guess this slide will be the most beautiful slide of all of my presentations, because all the other things are either screenshots or just black and white stuff, because I didn't bother to include any funny pictures as Stopa did, so sorry. Yeah. So what I will be talking about, this question, the topic of my presentation is, it's kind of, clickbaity. And first of all, I wanted to kind of ask the question that I'm asking. It's not really a question, it's a statement, but still I wanted to ask the question, is it possible to write an IDE in one day? And the answer is kinda. So I managed to do this in 1 week. By week, I mean that I did it in my spare time on weekdays, and I spent, say, like 5 hours each day on weekends. So in total, that might be like, say, 15 or 20 work hours. But still, I think it's very small time to accomplish something that big. By big, I mean that I was able to support some kind of cool IDE-like features in my custom language. Well, more on that later. And why did I thought about that? Well, on the previous meetup, there was a guy who talked about, Grisha Ivanov, he talked about the cool idea of language server protocol, and I was so fascinated by that idea that I decided, well, I might just as well go ahead and write myself my own language server. Well, then I thought that writing a language server for something like C++ or Python, it's boring because, there are already compilers and everything for those languages. But then I remembered that we have, a language at Wargaming. We call it Unbound, and we use it to write layouts for our UI in our game. We at Wargaming, we create a game called World of Warships. It's about ships which kind of shoot at each other, and it's a very cool game. It's very interesting. I played it myself, so I encourage you to do that too. Yeah. But yeah, I want to give you an introduction what the technologies for our client look like, so you'll have a little more background on why do we need Unbound and what it is, what does it look like. I'll show you this, the examples of the code. So we use, obviously, C++ for something heavy, like rendering or game logic that is built into the game engine. We use Python for high-level logic, and we have like hundreds of thousands of code of Python too, unfortunately. We have ActionScript for UI, and well, because we use ActionScript just because it integrates very well with an engine that we are using, and we use Unbound. So what is Unbound? Unbound, it's complicated. It's like a language that allows designers to create interfaces, but the designers do not need to know any kind of programming language. So it looks like a mix from HTML that you can define blocks. It looks like mix from CSS in a way that you can define styles. You can save them for later and then reuse. And it has a little bit of logic that you don't really ask your Python programming colleague every time you need to write something with logic. You can write simple stuff, and it's, as far as I know, it's usually just in a way of JavaScript ternary expressions, and that's kind of all that it has. But still, it's a pretty cool thing. It allows us to write interfaces for our game. Well, we usually hire the people who are mostly with designer background, and then they can create the interfaces, and it's pretty easy to write this. Especially if you already know how to write HTML. So this is kind of examples of the syntax. It's Lisp-like. I guess it has this kind of structure just because, for anyone who wants to parse the language later, Lisp-like syntax is a little bit more easy to parse. You can just write a recursive parser, and that's all. It's a simple stuff. On the right bottom, you can see the example of CSS. It's a kind of CSS style. On the left, you can see the example of a block. Here, you can see the more complex example of the logic. We don't really need to go into the details. I just wanted to show you the syntax. It's both simple and complex. It's simple because it's Lisp-like. It's complex because it has a lot of stuff going on. My grammar, it was like 300 lines. and I think it's a lot, but still. Yeah, so then I was talking about language server, and I wanted to write one, so I decided to write one for our language. First of all, I wanted to give a little more introduction about how one can write a support for their language. I mean, if you have a language and it's something that you want to execute, you'll need to go through all these phases, like lexical analysis, syntax analysis, semantic analysis, and all that stuff. I will cover only 2.5 first phases, lexical analysis and syntax analysis, because semantic analysis, it's something pretty complicated, and I won't be going into that detail, and I won't be talking at all about code execution and stuff, because well, it's already written in our language, and it's not something that the tool that I want to talk to you about is, yeah, it won't help with code execution. And the tool I'm going to talk about is Tree-Sitter. Tree-Sitter is a very cool library. It's written in C, and it allows you to generate parsers for any kind of language you want. I mean, I've taken this description right from the GitHub repository, and it kind of shows you the idea of the library. So it allows you to define grammar, and then it will generate the C code for the parser. It will generate pretty efficient code, so the resulting parser will be blazingly fast. I mean, it allowed me to parse source files with, say, thousands of lines in tens of milliseconds, so I think it's pretty awesome. And yeah, the main mode of usage for it is to be used as a Node.js package. Yeah, it will have some implications later, so that's why I want to mention it here. Let's start looking at how you might use it. Here we have an example for JSON grammar. It's also, you can have a look at this grammar on GitHub. It has its own repository, and I think these two pieces of code, it's already like 1/2 of the grammar of JSON grammar. The other half takes the various types of number literals like hexadecimal or octal or with floating point or without it. I wanted to give you a chance and try to spot an error in this grammar, because there is one, and I filed an issue on GitHub repository for it. But first, let me explain what's going on here. Do we have? Yeah. So the grammar is described as a simple. Do we have any kind of pointer here? Okay. But I think I'll just use this pointer. So. Sorry. Да дай, что происходит? Спойлеры. Так, оно работает? Yeah, so we have a grammar here. We define, Jesus fucking Christ. Yeah. Yeah, we have rules. Rules are defined as JS functions. You see here. Well, the name of the function is the name of the construct, the name of the node you want to have in your grammar. So, for example, in JSON, the root value will be something like object, array, or a number, or a string. Then the object will consist of pairs, and array will consist of comma-separated values. But yeah, the question still persists. There is an error, and if you've used JSON ever, you might just spot it. So, anyone? No. Well, I guess the error here is that you cannot use numbers as keys in JSON. And you can see here that object is the comma-separated pair of key-value pairs, and you cannot really use numbers, and this is the error. And I've fixed it and filed a pull request. Unfortunately, I guess the author of the package hasn't looked at it yet. But yeah, it will come in handy later, because by spotting this error and exploring it, I was able to look at the unit tests that are in Tree-Sitter library. But yeah, so first you write these kind of rules. They are very straightforward. You just see that there is a function choice that allows you to define that at the root there might be any kind of construct like object or array, you have this kind of function that is called sec. It's short for sequential. It says that for defining array, you first have to put this square bracket, then comma separated values, and that's so on and so forth. And yeah, that's pretty it. So this already is a very useful syntax for defining your grammar. Here we can have a node extras that defines that everything that is a white space is not a construct in our language, and therefore we won't use it. So yeah, let's go further. Then you run npm install. It will compilate your Tricito CLI dependency. It's a command line tool that might come in handy later. We might use it to generate our code. You see the third step where you run this tool, and by running Tricito generate, you will generate from this GS file the C code for your parser. It's pretty messy, so you don't have to look at it. Then you run npm install again to compile the parser, and then it's already done. So you've by running npm install the second time, you've compiled the parser, and you can use it by using the Tricito CLI command line tool or by importing your Node.js package. So here's an example of the files you'll end up with when you run Tricito generate for the first time. You see parser H, parser C, it's the source code for your parser. Binding CC is the C code for the Node.js binding for your package. Grammar GS is the grammar.js is the original file that you've started from. Package.json is the the definition of your package that you need to have in order to compile all your stuff. And the most interesting thing here is the grammar.json file. It's generated from your grammar.js file, and it might be useful for enabling some kind of cool support for your grammar in your tools later. For example, yeah, it's, I mean, you've seen the syntax here. It's JS functions. It's not really usable, but when you have grammar.json, you have declarative grammar, and you can use it later. I haven't used it yet, but I plan to use grammar.json to enable some kind of autocomplete or stuff. This is an example what you can have by running the Tricito CLI tool. So on the left, you have simple JSON document. On the right, you have the command line output from your tool, and it shows you the resulting AST, abstract syntax tree, and it also shows you the ranges of the characters in your file. The numeration obviously starts from 0, so you have the value that takes all the file, and the stuff like object with pairs, with the first one is string number, the second one is string array, and this third one is an object, and so on and so forth. So you, by writing your grammar.js previously and running the command line Tricito tool with an argument parse, you can already have this kind of support, and it already enabled me to test my grammar on all the source files that we have in our project, but it's not the main intended usage. The main intended usage is to use it as a Node.js package. More on that later. Here we can have here it's another pretty cool, I think, feature of this library, and it's an ability to write unit tests. You just define them in this kind of format, the name for the unit test, the value that you will parse, and then the abstract syntax tree that you want to end up with. And if you run Tricito test, you will have this kind of nice output that will say that, yeah, you passed or you haven't passed your tests. And anyone who have created their own language might agree with me that it is very, very important to write your tests. It's very important to have a comprehensive set of tests that will help you with the refactoring, with the evolution of your language, that when you will change something, it will allow you to see what breaks and fix it. Here is the list of the grammars that are already available in Tricito library. It's pretty comprehensive. I haven't put, say, like 2 or 3 languages that I don't know myself, so it's not really a good example. In development are grammars for C# and Haskell. And yeah, this list is pretty comprehensive. I've seen that I guess some editors, some companies might want to look into it by enabling support for this kind of grammar definitions in their products, but I'm not aware of them yet. So yeah, but if you want to build something for Go or Python or PHP, then you might use this kind of grammar. And if you've seen the syntax of the grammar.js file, it's very straightforward to use, and it's very easy. And yeah, I had great pleasure using this tool. There are already existing bindings for different languages. The JavaScript binding for Node.js, the author of the library wrote himself. The Rust, Haskell, and Ruby bindings are also available, but there is no Python binding, unfortunately. So at first I wanted to write my language server in Python, but yeah, it's not really an option. And I've seen the source code, the C++ source code for Node.js binding, and it's like several hundreds, thousands, several hundreds lines of code. So I decided I don't want to write that for Python in C++. I don't remember C++. So I decided to go on with the Node.js. So the first part of my presentation was about the tree-seater, the library that allows you to create parsers. And then the second part will be about language server protocol, which is the cool idea that Microsoft came up with, which will allow us to put the parser, the tree-seater parser, into any kind of editor and enable any kind of functionality we want to have with our language. So what is the language server protocol? It's the idea that you'll need two entities to parse the source code of your languages, and those are client and the server. The client, it records the keystrokes of your editor, it sends the source code from the client to the server, and it listens to the responses of the server. And the server does all the heavy lifting. It parses the code, it produces the AST, it produces all the diagnostics and reports the errors, and implements all that stuff that you are used to using in the modern IDEs, like go to definition and find references and stuff. But you might want to ask why split this in two. It complicates things, and the answer is it has a lot of benefits. The major benefit is that it solves the m multiplied by n problem. That means that if you want to support m languages in n editors, you'll have to write m multiplied by n plugins or programs or whatever. And yeah, it grows pretty quickly. There are hundreds, I guess, if not thousands, of already existing programming languages. But with LSP, you only need to write one language server, and then you will have to write, you'll have to write a plugin for each editor, but it's still n plus 1 and not n multiplied by n, so it's a great improvement, and I think it's a cool idea. The other benefit from it is that you are not tied by the technology that the editor uses. You don't need to learn Hacky, Lisp, or whatever the dialect of Lisp Vim uses, or Emacs. You don't need to learn, say, JavaScript for VSCode. You might just want to write language server in a language you already using, and I've seen examples like XML language servers written in Java and stuff. So yeah, it's pretty cool, and there are already a lot of language servers. This is an example of the website that Microsoft has for language servers. It has the specification, all the available methods for the language. It has the section of implementations, and there are lots and lots and lots of implementations. There are even like separate implementations for the same languages, so you might just choose whatever you like better. Here's an example of request and response. I haven't mentioned it there, but language server protocol is a JSON RPC protocol. It's pretty self-understanding what JSON RPC is. You just send the JSON request, and it executes some kind of function and returns you the JSON result. Here's an example for the command like find me the definition of the symbol in the file playgrounds/cpp/use cppy on the position like line 3, character 12, and the server goes there and kind of parses the code, finds the definition, and says that, yeah, the definition for your word is here in the provide.cpp, starting here and ending here. And from now on, I want to show you like the examples of what kind of functionality language server provides. So what kind of methods it has and what you can do with it. So for example, here we have publish diagnostics method. It's sent by a server, and it allows you to show the errors in your source code. Here we have an example in what? In PHP, I guess, yeah. You can also send warnings because there is a switch in diagnostic object that says whether it's a severity of error or a warning. There is an option to show something on hover. It's usually used for documentation or whatever there is. And I'm giving here an examples in VSCode just because I've looked into them the most, but I think it's possible to have this kind of support in any editor you want. I've seen implementations for IntelliJ IDEA-based solutions. I've seen language server clients for Sublime, and I guess for Vim, for Emacs, there are solutions that I've just haven't seen them. So here's an example for hover. Here's an example for signature help. It's the stuff that I've learned from IntelliJ IDEA-based IDEs, and I think it's pretty cool. And I just want to enable this kind of stuff into the language we are using because I think it helps. And yeah, you can do that with language server protocol. There is a method document symbol that allows you to parse the document and send all the symbols defined in the file, and it allows you to have this kind of stuff called breadcrumbs on the top, or the kind of stuff that's usually called outline or structure or whatever that allows you to easily navigate your code. And here you can see I've already have that available in our code. Yeah, and I think it also allows you to navigate your code pretty easily, especially if your files are thousands of lines long. And this is the stuff that I think our designers might like the most. It's the ability to show what the color for this hexadecimal value is. And yeah, I think you are also able to change the color, like to choose another, and the value will change correspondingly. So yeah, I think it's cool. I haven't enabled that yet, but yeah, I want to because I think it's cool. And the last one, and I think the most difficult one to implement, is the code action, and it's about all those useful things that that are, say, in PyCharm, it's with this light bulb. In VSCode, it allows you to do all the kind of intelligent stuff. Like you've missed the import, you might want to import the module from which the function you're trying to use, and yeah, all that kind of stuff. And yeah, it's very helpful. It's very cool that language server allows you to do this, but yeah, it's also, I think, the most difficult to implement, and yeah, I will look into it last. Here I want to just stop for a second and ask the important question. I mean, all the examples were about VSCode. I've ended up just writing all the stuff that I wanted for VSCode, but why VSCode? Why not Sublime? Why not IntelliJ IDEA, something like PyCharm? For example, at work I usually use PyCharm and I like it, and if I had to write anything for myself, then I guess I would enable support for this in PyCharm, but I don't use Unbound that often, so I don't need it. Our designers, they're usually code in Sublime. They don't like VS Code because it's not that pretty. It doesn't look that good, and it's yeah. I mean, it's subjective, but I've asked a few people, and they said to me that They also think that Sublime does font rendering better. I can say personally that Sublime is a little bit faster because it's written entirely in C++, but VS Code is something about C++, something about JS. So I wanted to write it for Sublime, but there is no Python binding, and there is already written Node.js binding by the author of the library. So yeah, I thought, well, why not? And it turned out that, yeah, it's pretty easy to enable this kind of stuff in VS Code. Another good thing is that there are these two kind of projects. The first one is the tutorial project from Microsoft, which allows, it's a heavily documented project which explains what's going on. And the second one is the one that I owe the implementation of my extension the most, because it's the implementation of language server for the Bash language. And yeah, it helped me a lot, so it allowed me to do all this stuff for VS Code. I wanted to show you the demo, but I guess I won't be having any kind of time for that. But I have the laptop with me, so if you are interested, I can show you how it looks like. Yeah, just because I personally use PyCharm at work, I was thinking that, if I wanted to use something to create something for my own usage, I would have created that for PyCharm. And since I was here, I'm doing it here in JetBrains office, I wanted to go ahead and look what it looks like to implement this kind of functionality in IntelliJ IDEA-based products. Well, I think the results are pretty controversial because it looks pretty heavy. All this stuff that there is in IntelliJ IDEA-based solutions, it does a lot. It can allow you to create your own parsers with YAC syntax. I think it's a little bit less understandable than the syntax that Tricitor uses, but it's still something that people used for ages. It allows you to create not only like add support for your language into the editor of your choice, but it allows you to create the whole IDE. And it allows you to do things that are not in language servers yet, but that are useful, and you might be already used to using them in IntelliJ IDEA-based IDEs. For example, things like what we have here, like renames or save delete refactorings or surround with or whatever stuff there is. I've looked, there are examples of those implementations in the SDK. It's possible to do that. You'll have to learn Java for that, of course, and I think you'll have to learn how to deal with the complex Java projects like Maven, Ant. I mean, it frightens me a little bit because I haven't written Java for a very long time, and I haven't written large Java projects, but still it's something that it's worth considering because, I mean, I wouldn't consider writing code in VS Code, like in Python, just because I think that IntelliJ IDEA, PyCharm, whatever, community edition or professional, it just serves me better. But yeah, if you want to look into something heavier than the editor, you might just go ahead and look up the IntelliJ platform SDK. You can just Google this kind of words, and on Google it will show you the stuff that you might need when you write a plugin for IntelliJ IDEA-based IDEA. But yeah, I haven't went that way. I've explained why, because I don't use the Unbound myself. And when I finally created VS Code-based extension and wanted to share it with my colleagues, I've found that there is a problem, and it's a big problem, that the parser that I'm trying to use, it's written in C, and in order to use it as a Node.js package, I have to compile it. And in order to compile it, I have to compile it with exact same Node.js version down to the third digit after the second dot, and yeah, it's messy. It works on Ubuntu. I haven't been able to do that on Windows, but if you do this kind of stuff. It's easy to do because it's just a server and a client. They are bundled in the same extension, and most of the people who are writing support for their own languages in VS Code, they do this kind of stuff. And it's how it should work, but you won't be able to do that unless you agree to stick to some version of VS Code and compile all your stuff for that kind of Node.js runtime. There is another option, but it has its own drawbacks. So you might write client as an extension and write server as a separate Node.js package. Well, you solve the problem, but you have another problems arising. You'll have to install server as a separate package that will allow to have incompatible server and clients if you upgrade your extension and you introduce some breaking changes. You will have to have Node.js installed. You'll have to have all the stuff that is required to compile your extension binaries, say like compilers, GCC or whatever. And yeah, it's a mess. I've looked into GitHub issues and they haven't solved that yet. They are even considering saying that you cannot use native Node.js modules in VS Code extensions. So yeah, if you want to use this kind of stuff, these are the things you'll have to deal with. I think for us, it's a viable solution just to stick with the one version of VS Code and then update it like once in 3 months or once in half a year, because yeah, there is no other way right now. But what I want to talk about now is how you might just go ahead and implement the stuff that you want to add into your editor for your own language. And I want to show that it's actually, when you already have AST, when you already have written the parser, it's very easy to do the basic stuff that you want to have. For example, how to provide diagnostics. The tree-sitter parser will show you that the node, is it erroneous or not? Is there a node missing at this point or not? And what you can do to provide diagnostic to draw all those red squiggly lines under the erroneous lines of code. It's just to traverse the AST, find error nodes, and publish general diagnostics like syntax error or there's something missing. I've mentioned the grammar JSON, and I think it should be possible to provide intelligent diagnostics. By that I mean that grammar JSON allows us to say that at this point we expected something like right parentheses, but we have here a digit or a letter, and yeah, we might just explain that in an error message. It should be pretty straightforward. I haven't done it yet, but I think it should be. How to implement go to definition, it's also pretty easy. You just look at your grammar, you say that what is the definition and what is reference. For example, with functions, that's the definition of the function body and the call. And then you traverse the AST, fill in the maps, which look like this. And that's all the preparation work you'll have to do. And every time that someone asks you to find the definition, you identify word under the cursor. I guess you just go to the right and to the left until you find the white spaces or whatever characters you don't consider significant in your language. Then you have that word and you look into your maps and find the positions and the URI. By URI, I mean the file where this definition is located. You see, to find the definition, you'll have to have a reverse map, like from definition to URI and position, but I didn't do that because you'll have to maintain 2 maps then, and it's, yeah, it's just more work, and it works pretty well for me because there are no definitions, not too many definitions, not too many references in our files, and that's why it works. But yeah, to speed up the things, you might need to have reverse maps. How to, yeah, these were the examples of how you might want to implement IDE-like functions. But if you have a look at these slides, you see I haven't mentioned the grammar or the specific language at all. It's just something that is like algorithmic, that is independent of language. And what I'm considering is you see here at the end of the slide is creating language agnostic extension. By that I mean that it should be possible that you just write your grammar.js and you copy paste it in somewhere in the extension, then compile it, and you should be able to do all that stuff and enable the things that you want to have in for your custom language in the VSCode editor. What I want to have in our languages for Unbound and Unbound 2, maybe to write unit tests, maybe to replace our own parser with the tree-seater based, maybe yes, maybe no. Yeah, as I said, we might want to consider providing intelligent diagnostics. We might want to consider providing better autocomplete based on grammar. We certainly want to display colors or add signature help. It's nice to have feature, but I think it's a bit complicated. And I mean, stuff that that's provided by the method code action of the language server, it looks pretty interesting, and I'm looking forward to implementing it. But yeah, it looks pretty nice. So what you need to take away from this presentation? I wanted to show you that breaking into the land of writing parser and compilers is pretty easy, especially with this library. I mean, I've went from wanting to write LSP to already writing it in like one day, and I like this library very much. I want to learn how the parser works because I think the guy did an awesome job implementing it, and it works absolutely great. The thing is that the only thing that stops me from looking into it a bit further is that I don't know how how all that stuff works, how it generates the code, what the C code does. It's pretty complicated, and yeah, it's like a black box for me right now, and that's why I won't be doing that into production. I won't be putting this parser into production unless I know how it works, and yeah, that's something I will be looking into later. The language server protocol idea is very good, and I think Microsoft did a very good job implementing it, and I think it's the future for all the IDEs and editors, and for all the language-based stuff in the future. I think that you might also want to consider implementing everything you might want to for IntelliJ, just because it allows you to do that easily and with not so. It allows you to do that easily, and if you are content with writing a little bit of Java, then you might end up not with editor with support of your language, but with something a little bit bigger. I guess I've skipped that slide, but the one thing that I like about IntelliJ idea IDEs that I don't have in our solution, in the solution in the VSCode extension, is that it allows you to create indices and to parse the AST that is already stored on disk, and it's already stored there in binary format in a pretty compact form. And yeah, it sped up things quite a bit. And if you have a lot of code, it will, the SDK that IntelliJ platform provides, it will allow you to create indices for your languages. Yeah, I think that's all. Thank you. And any questions? Yeah, sure. Let's start with you.
Check. So you've already mentioned that you're considering replacing tree-seater with something native in JavaScript, which probably a better idea, so we don't have to deal with packaging and stuff. But I wanted to mention that there is a tool called Package, PKG, for Node.js. It can kind of package your app into binary, which already includes Node.js. And as far as I know, it also supports custom native libraries, so you can try that. I mean, you can just ship this binary with your extension and run it. So maybe it will help you with the current code base. But yeah, I guess it makes more sense to Replace three-seater with something else.
Well, I don't really understand the question that you're saying.
No, it's not really a question. It's I just want to give you advice to try to this tool package.
No, I mean, you've said that I want to replace three-seater, but I've said that I don't want to. I mean, I've considered using this tool and like using it in production. I mean, I want to use this parser for our own language parsing stuff. I don't do that right now just because I don't know how it works. And I know, I mean, I can use it, but I use it as a black box. I don't know how the parser generates.
Yeah.
I see that it works. It works well on tens of thousands of lines of code, but I don't know how to fix stuff when it breaks. And that's something that stops me. But other than that, it allows us to, it allows me, firstly, to write the fast parser that is written in C. And yeah, I think your tool is a very good thing to bundle the stuff that I won't have to deal with binary incompatibility with the VSCode runtime and the binaries of my package. And yeah, thank you for that. I will consider it.
But now, for now, you just build for a specific version, right?
Well, the thing is that this is something that I do like for my own fun, and I haven't done it yet. I mean, it's working on my laptop in Ubuntu, but all of our designers, they are working on Windows, and I've tried building binaries for Windows, and I haven't had success yet. But yeah, I'm considering something like whether it's your solution or building the binaries for the specific node version.
Okay,
yes.
okay, thank you. And another question is not to you, but to JetBrains guys. What is your take on language server protocol?
I guess I can answer after the main speaker, not to spend his time questions.
Thank you. Anyone else?
Thank you for your talk. In the beginning of the talk, you said that your unbound language grammar specification has about 300 lines of code. Is it correct? Correct.
Yeah.
So I just opened a Python website and opened its grammar specification, and it's something about a little more than 100 lines. But you said that Unbound is a very simple language.
Well, you see that what I am doing, it's more of an afterthought. By that I mean that we already using this language for, say, like 4 years or so, and there is already a parser written in Python for this. And what I am trying to do is that I don't want to be to use the parser that we have because it's legacy code. It's pretty, I mean, it's pretty bad code written in Python, and the most well, the main idea why I don't use it for all this kind of stuff is that I cannot use it for a language server because it doesn't provide me with AST, with clear AST. It doesn't provide me with anything basically, because it was written for for one goal, to kind of translate the source code in Unbound into something. I guess it translates it into XMLs, and then these XML files are parsed by ActionScript, and this is the way it executes. Why my grammar is so large? Well, because as I have already mentioned, I'm doing this as an afterthought. I'm just creating, I'm writing the grammar and kind of looking at the syntax and thinking that, yeah, maybe this might be the grammar, and then I run it against our code and I see whether it works or not, and then add another node and another node. So it's kind of messy work. I think that I might be able to shorten our grammar a little bit, but that's something that I've did like in a week, and I wanted just to share it. I mean, it's still very early to say that this grammar is complete, and the second thing is the first version of this language was created without any kind of grammar. It just kind of was glued together, and that's why the grammar might be so complex.
So it may become shorter?
Yeah, sure.
Okay, thank you.
Yeah, thank you.
So, as I understood from your explanation of how LSP works, it kind of communicates between like processes which contains ASTs and user interfaces using like JSON or RPC. My question is, doesn't it create a lot of overhead, like in time? Like, did you notice like any changes in responsiveness in comparison, like with natively written extensions for languages?
Yeah, thank you. I think this is a very good question because, as I said, like writing everything bundled in together is a better version. It's a little more performant, and here we are talking about two entities which communicate with each other by using this protocol, and JSON is not a lightweight protocol. It's not binary. But I haven't noticed anything worth mentioning because I think it's what I think is important is that both language and both language server and the client, they both run on the same machine. So network latency is not a thing. The second thing is, well, that depends on the complexity of your language, I think, because if you're writing something like C++ with heavy metaprogramming, then maybe this kind of stuff isn't for you because the language server that I've written for my extension is written in TypeScript, and it might not be as performant as something like written in C++ or even Java. So yeah, I haven't run into performance problems, and I think I won't be, but yeah, this is kind of trade-off. Yeah, it is a little bit slower, but it allows you to kind of have this split between client and server, and it allows you to, as I said, solve all those problems, and I think it's worth it.
Thank you for your talk.
Thank you. Anyone else? Okay.
LSP not only stands for Language Server Protocol, but also for Lumpy Space Princess. Just for your information.
and what's Lumpy Space Princess?
Adventure Time. Have you ever seen Adventure
No.
But you missed an opportunity for a joke in the slide.
I guess.
Thank you. No one has questions? Oh, I just don't see you. Okay, so thanks you for your talk.